The development of unit hydrograph often takes huge amounts of data and information, and this kind of effort is usually done only for limited locations. For the locations where data is scarce, synthetic unit hydrograph may be developed instead. This type of hydrograph only requires empirical equations specially validated for target catchment. One of those methods is Snyder's method. In this method, the basin lag, which is defined as the time elapsed between the centroid of rainfall excess and the peak of direct runoff hydrograph, can be calculated using the following equation. Ct is a regional constant that varies between 0.3 and 6. Let's say we have a catchment with area of 500 km². The values of L and LCA are 50 km and 30 km respectively. On the other hand, the regional constant is taken as 1.23. By substituting the values, the basin lag is found to be 11.03 hours. Standard duration of effective rainfall, TR, can be calculated by dividing the basin lag with 5.5. For our case, the standard duration should be 2 hours. Let's say we intend to develop a 4-hour unit hydrograph which differs from the TR we calculated. This means our rainfall duration is non-standard, and to proceed, we need to adjust the basin lag. As a result, the modified basin lag should be 11.53 hours. The peak discharge of unit hydrograph associated with TR equals to 2.78 Cp/A/Tp. Cp is a regional constant which varies between 0.31 and 0.93. A is the catchment area in kilometers square. Note that Tp should be the modified basin lag if non-standard effective duration is used. In this case, given Cp equals to 0.66, our peak discharge should be 79.57 Qmax. The time base of unit hydrograph Tb equals to 72 plus 3 times basin lag time, and the unit of result shall be in hours. In our example, this found to be 106.6 hours. The width of unit hydrograph at 50% of peak flow is correlated with the peak discharge per unit catchment area. For the width corresponds to 75% of the peak flow, it needs to be calculated based on that for 50% peak. In our case, W50 and W75 are 42.73 hours and 24.42 hours respectively. A simplified model for unit hydrograph, namely SCS unit hydrograph, is another option for the synthetic unit hydrograph. This method is recommended by the U.S. Soil Conservation Services (SCS). The time base is defined by multiplying the time of rise with 2.67. The lag time, on the other hand, equals to 60% of the time of concentration. The time of rise is the time taken to the peak flow, and it can be determined after we know the effective rainfall duration TR and lag time TP. Once the time of rise is known, we can then calculate the peak discharge. Given a 50 km² catchment with the time of concentration equals to 80 minutes, let's try to develop a triangular unit hydrograph for 4 hours of duration. The lag time for this example is 0.8 hours. The TR is 4 hours, and therefore, time of rise equals to 2.8 hours. The peak discharge is found to be 37.14 Qmax, while the time base is 7.48 hours. With this information, we can plot the unit hydrograph with ease. Thank you for watching. If you find this video helpful, please share it with your friends. We'll see you guys soon. Goodbye.